In this video, we're going to look at series circuits, what these are, the rules for calculating voltage, current and resistance, and specifically Ohm's law. So what is a series circuit? Well, here is an example of a series circuit taken from page 16 of the course notes. And what defines a series circuit is that they're connected in series. That means in order, so that they form a continuous loop. They're formed in a line end to end. There's no side or parallel branches. So this is what we mean by a series circuit. And to understand what's going on in the circuit, we need to know about the three properties we've looked at so far in the course: voltage, current, and resistance. So let's start off with voltage. The voltage in a series circuit is found using Kirchhoff's second law. And what Kirchhoff's second law tells us is that the total voltage, which we represent as VT, and you'll sometimes see this written as VS, meaning V supply, is equal to the sum of the voltage dropped across each component. So say we had three components in a circuit, the voltage dropped across each of these components, that's the voltage to drive the current through each component. These add up to give us the total voltage for the circuit. And you can see an example of this on page 17 of the course notes with this diagram here. What we have is a circuit here with three bulbs, each with 6 volts dropped across it, and these add up to give us a supply voltage. If the supply voltage was lower than 18, the three bulbs would have to add up to give us that figure as well. So the first thing we know is what Kirchhoff's second law tells us, and I should write this here as well. Kirchhoff's second law: the voltage dropped across each component added up gives us the total voltage, or the supply voltage, in the circuit. The second thing about series circuits we need to know is about current. And the current in a series circuit is the same at every point. And I'm going to write here in series circuits because it will very clearly not be the case when we're going to look at parallel circuits slightly later in the course. So the voltage, total voltage, is given by the components add up, the current, same at every point. And the last thing we need to consider is the resistance. Resistance in a series circuit, total resistance in the circuit is similar to the voltage. It's the sum of the resistance of each component. So this is again illustrating if we had a three-component circuit, we'd add the voltages for each component. Of course, if there were more or less components, we'd have a resistance for each of those. So we add these together in order to find the total resistance of the circuit. So these are how we find information about the quantities in the circuit. The next thing we need to know about is how do these quantities relate to each other, and the way in which they relate to each other is using something called Ohm's law. I'll write that out here. Now, Ohm's law tells us that the voltage is equal to the current times the resistance. What does this mean? We'll define what these things are. We've got V is our voltage measured in volts. I is our current measured in amps, and R is our resistance measured in ohms. You'll sometimes see the symbol for resistance written as a capital R, and that's absolutely fine. It's the same as an ohm when you see that in the course notes or in tutorial questions. And Ohm's law tells us the relationship between voltage, current, and resistance for the whole circuit or for any individual component. So let's quickly look at what that means. If we're considering the whole circuit, then the voltage that we're dealing with is the supply voltage. That's the voltage coming out of our battery. We usually write I with a little c next to it to say that the current in the whole circuit. And then R, we'd represent it by R with a little t here, a subscript to say the total resistance in the circuit. So this version of Ohm's law is what we use if we're calculating a quantity based on the full circuit. So if we knew the voltage supplied and we knew the current running in the circuit, we'd be able to work out the resistance, and the same with any other quantity. If we were dealing with only one component in a circuit, say the component we decided number one, the voltage dropped across that component in a series circuit is going to be equal to the current in the circuit, because if we remember, our current is the same at every point. So this current we've got into the circuit is the same at any point in the circuit, same in every single component in the circuit, times the resistance of that particular component. So if we had a resistor that was 100 ohm resistance and with a 3 amp current, 3 times 100 would suggest that'd be a 300 volt supply, which is quite high, which is quite a silly example I've made up. But that's how the calculation would work. So these are the pieces of information we need to know. Now, it's most useful to put this into a couple of examples. So let's look at a couple. First of all, we'll take the example from page 26 of the course notes. I'll put this up on the screen just now. So here we have a very simple circuit, and we have a battery with a 6 volt supply. We've got a push switch, we've got a lamp, and this arrow isn't a component at the bottom. This is just telling us the direction and size of the current. So we have some information here. And although this is a simple problem, we should tackle this in the same way we would any other engineering calculation. We should list the information we have first of all. So our supply voltage is equal to 6 volts, and our circuit current is equal to 0.06 amps. And we've been asked to find the resistance of the lamp. And in this case, the resistance of the lamp is a total resistance for our circuit. We've only got one component here. So the total resistance is the same as the resistance of the lamp. So we can call this whatever we want, or you could call it R1. But it's absolutely fine just to stick with RT just now. And we don't know what this is. Well, Ohm's law tells us we can find the resistance using V equal to IR. And because we've only got one calculation, I'm not going to worry too much about these little subscripts here. So we're dealing with a voltage, a current, and a resistance. So V is equal to IR. So we can rearrange this in order to find an equation for resistance. So we divide both sides by I here, and that gives us R is equal to V divided by I, and we put our numbers in, and we have 6 volts and 0.06 amps, and 6 divided by 0.06 is 100 ohms. And units are always very important in engineering, no more particularly so in electronics, but they are important to include here as well. So we've got an example of using Ohm's law, and we use some of the information we knew about the rules for series circuits there as well. Now let's look at a slightly more complicated example from page 27 of the course notes. We'll start it up here. This is a series circuit. We could see that from the diagram even if we weren't told it in the question, but we're asked to find the total resistance, the circuit current, and the potential difference across both resistors. That means the voltage dropped across each resistor. So let's have a look at how we can find out this information. Well, the first thing we're asked to find is the total resistance. So I'll write A up here. Now, if we remember what we said about series circuits right at the start of this video, the resistance for the total resistance is equal to the sum of all the individual resistances. So we have two components in this circuit, two resistors, and so what we know about series circuits tells us the total resistance is equal to R1 plus R2. So putting in the numbers we've got here, R1 has a resistance of 6 ohms, R2 has a resistance of 18 ohms. Adding them together, we get a total resistance of 24 ohms. So that's part A. Part B, we're asked to find the circuit current. And for this, we again think about what we've looked at so far. If we know a resistance and we know a voltage, we have a rule for this. It's Ohm's law, which is stated by V is equal to IR. And in particular, if we're dealing with the whole circuit, we can say that the supply voltage is equal to the circuit current multiplied by the total resistance. And we have two of these things. We've worked out the total resistance in part A, and we've been given the supply voltage in the question. So we can just write these here. Supply voltage is 12 volts. The total resistance is 24 ohms. We can rearrange our formula for Ohm's law to give us current. So the circuit current is equal to the supply voltage divided by the total resistance. So putting in our values, we have 12 divided by 24, and that's equal to a half, or 0.5 amps. And so we found our answer for part B. The last part of the question, we're asked to find the potential difference across both resistors. So the potential difference or voltage across V1 and the voltage across V2. So let's see what we're going to do here. Now, if we look at resistor 1, first of all, circle it in red here, if we want to consider resistor 1, we know that the resistance, we've been told in the question, is 6 ohms. And because this is a series circuit, if we go back to the start again, the current is the same at every point in a series circuit. So that means this value for current that we've worked out in question part B is going to be the current that's running through that resistor. So the current's the same at every point. So we can use the circuit current here of 0.5 amps. And the thing we're trying to find, well, that's the voltage dropped across resistor 1. We'll call that V1, and we don't know that. So again, we can use Ohm's law. Ohm's law can be used for the whole circuit. It can be used for individual components. And V1 is going to be equal to IC times R1. It's going to be equal to the current, which is 0.5. We just worked that out, multiplied by the resistance 6. And that's a total of 3 volts. But we were asked in part C to find the potential difference across both resistors. So we could just repeat the exact steps we've carried out there for resistor 2 and work out the voltage that way. Or we could also remember the final thing from our definition of a series circuit, and that's the voltage. The total voltage is given by the voltages of each component. The voltage being dropped across each component add up to give us the total voltage. Well, in our circuit here, we have two components. So what this rule, what Kirchhoff's second law would tell us, is that our total voltage is going to be equal to the voltages V1 plus V2, the voltage dropped across each resistor. The total voltage is our supply voltage of 12. We've just worked out that V1 is 3, and that leaves us to find V2. Subtracting 3 from both sides tells us that V2 must be equal to 9 volts. And that completes the example. And this example takes us through all the facts we know about series circuits and also uses Ohm's law in order to find the quantities that we need to calculate. So on page 28, there's a series of exercises about series circuits, and having watched this video, you'll be able to carry them out just now. Question 1 in particular is quite similar to this example, so if you have any challenges with that, come back to the video and have a look and see if you can solve it that way.